Swayam Prabha. Digital India. Educated India.
Welcome back. In module 4 we will learn about Python. We will learn about the fundamentals first, and then we will go into more complicated programs. So lecture 16 is all about introduction, basic introduction to Python. So the different concepts that we will cover will be on programming basics, how programs evolved, how the programming languages evolved. Then we will introduce you to Python, and then we will talk about how to install it and where you will find the documentation. We will talk about what are Python libraries and about the integrated development environment for Python programs. So coming to programming, most of you has some idea about programming, but if you don't, basically programs, what it is a structured set of instructions. That means it is a set of instructions which are given together, and those are executed in the computer to do some kind of task. So it is a process of logically and systematically designing and writing instructions that a computer can execute, and a task is being performed. So it has to be a logically and systematically written. So that means there are some rules in which has to be followed while writing a program, and it has to be logical, right? It cannot be random, commands. So programs, of course, require some amount of data, because a program is a set of instructions. It has to act on some data, and once it acts upon some data, it would give you or some output, right? Now it may not be based on data directly, but it could be so that it's a program running in the operating system, which takes into input as some system variables, and then it triggers. For example, if the if the hard disk is filled, there may be a program which triggers, which gives a prompt that would you like to clean the hard disk, right? So that means some amount of data or information gets into, and then it does something. So this programming, of course, allow automation of repetitive, complex and data intensive tasks, and that's why programming is fundamental in today's context, where we use computers and so on. Now there are basically different ways the programs could be written, and depending on the scale of the program or how intense it is, we can divide it. We can say that there are scripts and then there are applications. Scripts are basically a lightweight program. That means you write one page of code, or maybe a large page of code, doesn't matter, but still it's it doesn't have many dependencies, many modules and so on. But if you have a full scale, suppose we have an organization and we have different entities, different departments in the organization. Each department works in a different way. So I will have many programs written, and then those programs would be connected, or those would be packaged together. That's an application. So it's a complete software system that is being designed. So for example, as I was telling you earlier, that we are developing softwares for public transit system. So there are 80 databases. So obviously there may be many modules which talk to each other. Those are being designed, and or which depend on data. It is in the database, these modules are connected, but each module gets data from some of the tables, and then processes it, does something, or updates the values, or just displays something and so on, right? But these are all connected at the back end, which is the database. So Python is widely used for scripts and analytical programs, which makes it ideal for urban analytics. That is why we should learn Python, particularly when we want to get into machine learning and all. You have to learn Python. And Python is also a very data centric language. That means that it can handle lot of data sets. It is designed to handle data sets and manipulate data sets, and it supports tables, vectors, matrices and other data structures. Now looking into the evolution of programming languages, now initially there was something called machine language, and eventually nowadays also it doesn't matter. A computer at the end of the day understands only zeros and ones, right? So it's a binary way of putting information, like okay, this is yes or no. Like that we store all information in computers. So earlier any information that has to be given, either it has to be in this particular format, right? So it were binary instruction, these were hardware specific. Every hardware, that means every company's computer, the instruction sets were different because they use different processor, different memory. So the way I have to send the command is different, right? The only language the computer, this is what the computer understands, right? Now we can always keep on adding layers of abstraction to it. Means that whenever we are having, this, the computer understands 1 0, but I can write a set of code, say that okay, this set of instructions which are repeated again and again, I can give them a name and make them into one instruction. So that is when these assembly languages came. So it is a symbolic representation of machine instructions. That means it's a group of instructions taken together. It is again zeros and ones, but it is still, you don't need to write it in that form. You can give those particular instructions, which is still very, very detailed. It is little more readable, but still it is very, very hardware dependent and complex. So that is where, it's mostly, these are known as low level languages, right? Because this is through which the computer directly interacts, right? But if I go into more higher level languages, that is where human can actually participate in writing programs easily, not very, not very specialist, anybody can write a program and all, and the commands that could be given in something which a human being will understand, right? That is that means by reading it you can make sense of what is being happening. So it's a human readable syntax was introduced in high level languages, and that is when procedural oriented programming came into place. So the first language was of course C in this particular case, C and some others, right, Fortran and all. Now programs in this particular way, when what happened is the way programs written was changed. That means there were a lot of instructions which were standardized. That means if you want to print something, the print command came in. If you want to take input something, suppose there is an input command, right? What is happening when you type in input is all written at the back end. So that means the program, when you type input, when it compiles, right, when you run the program at the end, it will create a compilation and convert all this into ones and zeros instructions, and then it runs at the back end. It runs in the in your microprocessor, right? But at the end of the day, the human being the person doesn't have to get into so much details. He can only learn the syntax of the C programming language, and then he can write his programs. This is one part. The other part is, of course, it was organized in state by state procedures or functions. That means we have a group of functions, and each function performed a different task. And we used to have global variables. That means we declared certain entities, you can say, and then these variables are actually the value that you put in these variables are passed on to the functions, and the functions execute something and returns back some value. This may be taken by another function as the input. So in this way, the programs were developed as a series of functions, all interdependent among each other. So this is the next part, but this actually has got a lot of issues and all, and to make life more easier, or you can say functional programming was introduced, which is object oriented programming, like C++, the languages that comes under that is under C++, Java and so on. What happened was programs got organized around objects. That we will discuss this in detail later on, of course, but what it means is we are dividing, instead of focusing on procedures, what we did was we say that okay, this program is about something, right? If the program is about payroll of a department, so it is, that means the entity is either the people who would get paid, or it would be a payroll roster. So this becomes the entity. So based on that particular entity, we were writing programs. So there will be some variables where we will store some data. There will be some some programs which will do something with the data. Like for example, it will add data for the entire year, like every month's salary, and then say the total salary, right, for the entire year. So that's that means there are some functions also built in. So it's a combination of functions and data which is packaged together in form of a object or a real life entity, and these real life entities talk to each other and they can pass data between each other, but in a structured way, and this is object oriented programming. So this actually has got a lot of benefits which we will discuss later. Then came scripting and data-centric languages like Python and R. So this is also object-oriented programs, but it, along with that, it has got, because these are more lightweight and more easy to write and more, feels more normal, like it's like a normal script that a human being can understand. The learning curves becomes very less. That means you can learn it very fast. So it allows more automation, rapid development, and also it is interpreted execution. That means as you write each line, it gets interpreted if it's right or wrong, and then it gets executed. So you don't have to compile it at the end and then there is an error returned, and it's not like that. Every line you write, you will be shown what is error, what is the problem. You can keep on correcting, or you can execute each line, see what is happening, and you can keep building upon it. So Python is a interpreted, object-oriented, high-level, general-purpose programming language, and it is of course one of the most fastest-growing language in terms of predefined libraries. Now, libraries is the most important thing when we talk about this high-level language. Why? Because one side is, of course, the syntax has become easier. The program can detect what you are writing is a number or a string, is it an integer or a float. So automatically it can assign variables and the data types to it. And the way you write code becomes very normal. That means you won't have any problem understanding what it is talking about, right? There are some syntax, of course, but it is not that difficult to learn. On the other side, it's using this particular, when you are using Python, you get a lot of libraries which are written. Libraries, we will discuss libraries, of course. A library is a collection of pre-written reusable code. That means it includes functions, classes, modules that provide specific functionality and could be imported and used in a program. For example, I am doing statistical analysis. So I can import a library which supports that. That means I can import, suppose a library, if I want to do organized data and all, I can import Panda. And then within Panda, there are many functions written, many classes are there, which could be called as per my requirement. So I don't need to write any code for that. Already this code is written, I just need to know what does what, and I can directly call that function, pass in my arguments to that particular function, and I get the output from that particular function as I expect. So that is what gives power to Python. So it has got huge amount of predefined libraries for machine learning, libraries for statistical analysis, libraries for visualization, hundreds of things. And it's and usually the syntax is very human friendly, and everything is processed at runtime by the interpreter. So that's why we call it interpreted. So interpreter is a program that runs the scripts line by line, whatever you are typing in that particular, the Python code, and there is no separate compilation step that runs at the runtime. That is, when you run the program, there is separate compilation happening, error is returned. No, it doesn't happen like that. And errors are immediately detected during execution, and immediately you can rectify them as well. So as a result, it is easy to learn. It has got, because there are so many libraries and all, you can do a lot of data analysis and widely used in research, and it can integrate with GIS, databases, APIs, machine learning, everything, right? So Python is very, very integrated with many other things that we will usually use in urban analysis and so on. So as discussing regarding libraries, so libraries are of course it's a pre-written code and all which we are using. So these are reusable. I can call the same library multiple times. Once I call it, I can use different functions of that library multiple times. Then these are modular, and because this is already written, then we can save on development time. And then very lot of basic problems of maths, data analysis, plotting, GIS, ML can be solved using libraries. And then there is that integrated development. Once this library, along with libraries, Python also comes with integrated development environment, IDE, and this is where applications that provide a full environment for writing, running, debugging, and managing programs. Now, where do I start? So officially you can start from the official Python distribution, which you will find from python.org, and you can download that from there. And currently Python 3.15 is in development, version 3.15, and version 3.14 is a stable version which you can download. Or otherwise, what I will recommend for you is to download the Anaconda distribution. So this is basically a standard Python, but along with that there are a lot of pre-installed libraries. You don't need to install them separately. They come as a package. So along with that, it also comes with something where you can type in the code or you can check. So that's the Jupyter Notebook, right? It offers an interactive environment where code is written cell by cell and the output, text, tables, plots appear within that particular, that particular window itself, right? And this is good for, you learning the application and then doing some experimentation by writing code. So this is of course good for that. So along with Jupyter also you get the Spider IDE, and which is the Spider, which is the working environment coming from the Anaconda, and you can download this entire thing from over this particular anaconda.com products/individual. And Spider is a desktop based scientific IDE where code is written as scripts like Python files. You can save all these program files. .py is the extension of those Python files, and it is good because if you have got structured programs, big programs divided into many parts, a lot of classes and large scripts, better to use a desktop IDE instead of using something like Jupyter, because you can lose that information. And this also includes variable explorers, debuggers. That means we can keep track of what are the variables we are introducing. It helps in debugging. There is a console where I can type in and I can see what is the result of that particular code, and so on. And if you want to study more about Python, we will of course teach you quite a bit of it, but at the same point of time you can also go to the Python website for directly looking into the documentation and so on. So this is how you install Python. Once you go to the website, you download and then you run it, and you can you can allow it to create shortcuts and all, or you can do it a custom location as well. And then once it is completing, this is how it looks. Over here you can see another ID called PyCharm, but this has to be downloaded. It doesn't come by default. Spider comes as default. And this is the Jupyter Lab, which you can see over here. You can launch it from here, or Jupyter Notebook over here, you can launch it. And once you launch it, you will be able to, it will be done. Just this is how it looks, the Jupyter, this notebook. You can type in the comments over here, and you can execute it and you will get the results. And this is the Python documentation. Here you can check what are the information that is there for, particularly for Anaconda, this is there, right? But you can always go and separately look for each library documentation and so on, and you can run the Spider as well from this. So this is how the Spider ID looks like. And on the left hand side you will see that this is where you can type in the code and you can run it using this this button over here, and you can see the results over here. It will give you messages that what is the error, everything you can see on this side. So Python offers multiple libraries, and with libraries there are packages and modules and so on. So a Python library is a collection of packages that provide related functionality. So suppose it's a machine learning library, so there will be many packages within that offering different kinds of machine learning tools. A package is a collection of modules organized in directories, of course, and a package typically contains an __unit_.py file, which signifies that this is a Python to the Python interpreter that the directory should be treated as an entire package. And a module is a single Python file that organizes code and may contain functions, classes and variables. We will of course learn about what are classes later on, but functions we already know. We will show you that how to write a function, and then what are the different variables or the data or the memory location, or the different types of variables where we stored some amount of data. And to use functions or classes defined in a modular package, you can actually import them in your program. So when you type in a Python program, we start with import that name of that package, so I can directly use the classes or the functions of that package directly. So these are some of the packages you can see. We will briefly describe this. So the Pandas library is used for data manipulation and analysis mostly. So it contains functions which allows you to do that. It allows importing of many file formats also, like CSV file and so on. and it allows many data manipulation, data cleaning, all these things could be done via this pandas, and this is the documentation. You can go to the documentation and you can check what are the functions, procedures, classes offered within this library. So then there is NumPy. It stands for numerical Python, and this provides a fast, efficient mathematical operations on n-dimensional arrays of data. Python offers very rich data structure. We will show you subsequently. But arrays and standard arrays of course. But if you want to use different dimensional arrays, arrays are data structures where you can store matrices and so on. And if that's an n-dimensional array, that is where you will require NumPy package. So documentation again could be accessed from this particular address. Then there is stat models, which of course from the name itself you can understand it offers functions for statistics. It provides classes, functions to estimate many statistical models like linear regression, logistic regression and so on, and this is its documentation location. And then we have got SciPy, which is a scientific computing libraries that is an advance on NumPy and provides many more functionalities which allows us optimization, interpolation, eigenvalue problems and many other kinds of applications. And again you can find the documentation here. Then coming to scikit-learn, this is a machine learning library. We will use that extensively later, and you can do classification, regression, clustering, all these things using scikit-learn. So there are many other machine learning library. Of course TensorFlow is one. So it is again an end-to-end open source platform for machine learning and deep learning. So it offers various tools and libraries to develop and deploy AI models, and this is again this is the documentation where you can get that. The address where you can get that documentation on TensorFlow. Then there is Matplotlib, and which is a library for creating static, animated and interactive visualizations in Python, mostly static though. And you can plot graphs, charts and other visual representations using this library. And then there is Keras, which is an open source deep learning API written in Python running on top of TensorFlow, and it provides also user-friendly interface for building and training neural networks and so on. So again you can say these are different types of libraries which some are exactly not libraries, but we can call them from Python programs and we can execute the functions and classes within them to do many advanced tasks. Now coming to the integrated development environment, we have already talked about Spider, and then there is PyCharm. Then what it does is basically all these IDEs, they provide a comprehensive set of tools to help programmers to write, debug and test code. That means it helps us allows us to type in the code. So there is a code editor, and it can do auto completion of the code. It can highlight some syntaxes like the main the variables are in different colors, the commands are in different colors. Then there is a debugger there which can help in testing the code continuously and identifying and fixing errors. Then a compiler or an interpreter is there through which we can which changes the code into that zeros and one or the machine learning format which actually executes in the processor. And then version control can be done via integration with GitHub for tracking which version of the program it is. I can keep on updating the program and add new versions, and then we can totally automate the build as well, and this will also reduce repetitive coding. So these are the tasks. That means certain tasks could be automated. So PyCharm is there. You can download that. You saw the option there earlier, and it is used mostly for professional development. It supports code completion, debugging, version, most of the things that we discussed. Same goes with Python. It is mostly for scientific and it provides a more scientific environment and helps us in data science and scientific computing, but I think all of them could be used for most of the things. And again, Variable Explorer integrated with NumPy, SciPy. So it becomes a very popular choice because all this, you get access to all these particular inbuilt libraries as well. Then there is the Jupyter Notebook, of course, and again you can use that directly, but you can test code, live code, you can practice testing on that. Then there is Google Colab. It's Google it's a cloud-based interactive computing environment, but what it helps is it provides you free access to GPUs and TPUs. Sometimes deep learning and other kinds of data science projects requires a lot of computing power, and that is where this actually, because it is run in the cloud, you can get help of those GPUs and TPUs, right. So then this is where you can access that, and then there is Visual VS Code or Visual Studio Code. This is again a very common editor. It could be used to edit many languages such as Python, JavaScript, C++. So it could be that common tool that you can have, and it again allows debugging and supports multiple languages, Git integration, and so on. So these are some of the references you can look into. And to conclude, Python is a versatile high-level programming language that combines procedural, object-oriented scripting and data-centric programming styles with a single ecosystem, and because a lot of libraries are available. Its extensive and continuously growing collection of libraries enable efficient handling of urban data sets, statistical analysis, visualization, automation, and modeling. Thank you.